Good evening, students. Today you are going to learn about isotopes. Before I start explaining isotopes in details, let me tell you about two very important terms which are related to isotopes, and they are atomic number and mass number. All of you must be knowing that there are three subatomic particles, that is negatively charged electrons, positively charged protons and neutral particles neutrons present in an atom. And there are two parts in an atom also, which are the nucleus, which is present at the center of the atom, and the another one is the extranuclear part, which is present outside the nucleus, and they are also called energy shells or orbit. Now out of these three subatomic particles, protons and neutrons together present in the nucleus of an atom, and that is why these two subatomic particles, protons and neutrons together, are called nucleons, as they are the particles of the nucleus, whereas electrons are revolving around the nucleus in different energy shells or orbits. Now, since electrons are present outside the nucleus in different energy shells or orbit, they can easily take part in the chemical reaction. Means an atom can easily lose or gain electrons because they are present outside the nucleus in different energy shells. Now, among these three particles, only protons and neutrons, these two have mass, whereas electrons have negligible mass. So we can say that electrons do not have any mass. Only protons and neutrons have mass. So protons and neutrons are the particles which only contribute to the mass of the atom. That is why the total number of protons and neutrons present in the nucleus of an atom is called the mass number of that particular atom. So that's why mass number definition is like this, written over here. You can see total number of protons and neutrons present in the nucleus of an atom of an element, whereas only the total number of protons present in the nucleus of an atom is called atomic number. So mass number is equal to protons plus neutrons. Why? Because these two particles together contribute to the mass of the atom because they have mass. Both of them have mass. So that's why their total number together called mass number. Whereas only total number of protons present in the nucleus called the atomic number. Mass number is represented by capital A, whereas atomic number is represented by capital Z. So from this we can write that mass number A is equal to protons plus neutrons, and in the next line you can see that proton number is replaced by the symbol atomic number, which is Z. So A is equal to Z plus neutron. Now out of these three terms, if any two are known to you, then you can easily calculate the third one. Okay, and vice versa. So suppose if A and Z, that is the mass number and atomic number, are known to you, then you can easily calculate number of neutrons. How? Mass number is known to you. So if atomic number is subtracted from mass number, you will get the number of neutrons, right? Because mass number means protons plus neutrons. So if you subtract number of atomic number, that is number of protons, from total number of protons and neutrons, then what we will get? You will get number of neutrons. So that's all about atomic number and mass number. Remember how to calculate number of neutrons. Just A minus Z, that means the atomic number must be subtracted from the mass number and you will get number of neutrons. So hope you have understood the concept of atomic number and mass number properly. Now let's get back to the main topic, which is isotope. The definition of isotope is like this. Isotopes are the atoms of an element or atoms of the same element which have same atomic number but different mass number. Let me explain you the concept of isotope with a suitable example. You can see the first example which is written over here is the example of hydrogen. Here you can see 3 hydrogen atoms are written which have same atomic number. You can see 1, 1, 1, and same atomic number means they have same number of protons. Now you must remember one thing, that atomic number not only represents the number of protons, it also tells us about the number of electrons. In an atom, the number of protons is always equal to number of electrons. So if in hydrogen atoms there is 1 proton, that means electron also 1. So atomic number 1 means number of protons as well as number of electrons is 1. Whereas you can see mass number, which is different in all 3 cases. The first one, which is a normal hydrogen also known as protium, has mass number 1. The second one, which is deuterium, which has mass number 2. And the third one, which is tritium, having mass number 3. Now, why do isotopes have same atomic number? Because they have same number of protons. Now, why do isotopes have different number of different mass numbers? The reason you can understand, we know that mass number is equal to protons plus neutrons. Now if proton number is same, then why mass number is different? Definitely due to the different numbers of neutrons present in the nucleus. So therefore we can say in these 3 hydrogen atoms, only due to the different numbers of neutrons present in their nucleus, they have different mass number. And how to calculate the number of neutrons? I have already mentioned you how to calculate number of neutrons. You have to subtract atomic number, that is number of protons, from the mass number, that is from the total number of protons and neutrons. So here mass number is 1, atomic number 1. So 1 minus 1 means 0. That is, this hydrogen atom does not have any neutron present in its nucleus. So number of neutron is 0. Whereas the second hydrogen atom, mass number 2, atomic number 1. So 2 minus 1, which is equal to 1. So the second hydrogen atom has only 1 neutron in it. The third hydrogen atom, mass number 3, atomic number 1. So 3 minus 1 is equal to 2. That is, the number of neutrons is 2. So you can see the difference in the number of neutrons, which is 0, 1 and 2, but number of protons are same in all the cases, which is 1, 1, 1, and number of electrons also 1, 1, 1. So out of these 3 subatomic particles, an isotope will always have same number of protons, same number of electrons, but different number of neutrons, and that is why they are called isotopes. Okay, the second examples you can see, that is the example of chlorine, which have again same number of, both the chlorine atoms have same number of protons, that is same atomic number, same number of electrons as well, but due to different number of neutrons, they have different mass number. How many neutrons this chlorine atom has? 35 minus 17, that is 18, and this chlorine atom has 37 minus 17, that is 20. So number of neutrons in the first case 18 and the second case 20, but number of protons and electrons is 17. So these are these 2 chlorine atoms are another example of isotope. Here also some more examples are written, which is the example of carbon and oxygen. You can see carbon also has same atomic number, that is same proton number, same electron number, but due to different number of neutrons, they have different mass number. Oxygen also same number of protons, same number of electrons, same atomic number, and due to difference in the number of neutrons, they have different mass number. So these are some examples of isotopes. Now we will learn about the properties of isotopes, physical properties and chemical properties. Remember that isotopes of an element always have same chemical properties but different physical properties. Let's understand with a suitable example. If we consider the isotopes of hydrogen, you can see 3 isotopes, 3 atoms of hydrogen are written here. And these 3 hydrogen atoms will always have same chemical properties. If we consider the chlorine isotopes, all the chlorine isotopes will always have same chemical properties, and same goes for carbon and oxygen isotopes also. What is the reason behind it? Reason is chemical properties are the properties which actually depend on the number of electrons an atom has. Now in all isotopes, you can say, if we consider the isotopes of hydrogen, you can see they have same atomic number. Therefore that means they have same number of protons as well as same number of electrons, which is 1. If we consider chlorine isotopes, you can see same atomic number, therefore same number of protons and same number of electrons, which is 17. And for carbon, same number of protons, same number of electrons, which is 6, and for oxygen, number of electrons same, which is 8. Therefore we can say that the isotopes of a particular element will always show same chemical properties, okay, because chemical properties always dependent on number of electrons and the electronic configuration of that particular atom. If number of electrons are same, then obviously electronic configuration is also same, and therefore they will have same chemical properties, because as I already mentioned you earlier that electrons are the subatomic particles which take part in the chemical reaction. So therefore if electrons number of electrons same and the electronic configuration same, then chemical properties will also be same. Therefore, we can say that we can conclude that isotopes of an element, of the same element, will always have same chemical properties. But remember that isotopes have different physical properties, because physical properties are the properties which depend on the mass number of an atom. So we know that in isotopes they have different mass number, and that is why they will have different physical properties, because physical properties are the properties which completely dependent on mass number. Which properties are called physical properties? Like mass, and some properties which are related to mass like density, volume, conductivity, solubility, boiling point, melting point. All these properties are dependent on the mass of the atom. Therefore physical properties like mass, density, volume, conductivity, solubility, boiling point, melting point, everything is dependent on the mass of a particular atom. Now since mass number of isotopes are different, therefore we can say they will also show different physical properties. So from these we can conclude that isotopes of an element will always have same chemical properties, but they will always show different physical properties because they have different mass numbers, and physical properties actually dependent on mass number. So that's all for today. I hope you have understood the concept of isotopes properly. So if you like the video, then please do like, share and subscribe.